Okay, this is 454. We have a bouncing ball that we are trying to see what type of model would be best. So I'm going to start with a graph of the original data, bounce, and the height. Again, notice that's pretty curved. Let's add a least squares line and make a residual plot. And notice there's definitely a curve, a straight curve. So don't remember, even though r squared is not bad, it still has a curve, so we should continue on and look at the next type. So I'm going to take the log of both. So let's do log of the bounce data. So to do that, I'm now immediately look, there's an issue. We already have a problem with plugging in 0, right? Because you can't take the logarithm of 0. So we that probably means that anything that's going to use the log of the x value probably isn't our best way to do it. Let's do the log of height and see what we get for that. That's going to be log of height. Okay, that's not too bad. So let's do a new graph. This is going to be based on the bounce and log of height. That doesn't look too bad. Now, because we did x versus log of y, this is the exponential model. Okay, so when we do this, we have a least squares line and we have the residual plot. This is a lot better. There's not much of a pattern, and you get a pretty strong r squared. So the least squares regression line in this case is, and we'll come back to that, is right here. Log of height equals negative 0.119 times the bounce plus 0.46. Now, part C tells you to do an inverse transformation. Remember, you don't really have to do that. What you can do to predict the height of the ball's 7th bounce is just plug in 7 in for bounce and get your answer in that case. Okay? And that is basically, even though I didn't type and put in all of the what you would write, this is basically what you would do to find the exponential or the power.